this demonstration, I will show how SecuPi can be installed as a transparent gateway or an application overlay. We'll use a DB tool, dbeaver, to connect to an underlying data source, Postgres, and be able to connect to it without specifying the password for the user doing the connection. So passwordless connectivity to the underlying data source. We'll show us SecuPi can intercept that connection request of the user. In this case, it will pop up a single sign-on logon screen for Okta. That user will be validated in Okta, and then using the SAML assertions within Okta, be able to access the underlying database. Once the sign-on is approved, we'll be able to connect to the underlying database using the password vault for our service account in SecuPi, insert that into the user's connection request, and then be able to connect to the underlying database without actual knowledge of the production database user ID and password to be able to do so. We'll then show some of the monitoring and auditing capability that SecuPi provides based on the requests that we've seen from that user. So first, I'll log into my database using dbeaver. Once again, it's going to be a Postgres database, and I have two different users defined, Gall tester and Dana tester. If I try to connect as Gall, so we can see the sign-on screen is presented, it brings me to the Okta sign-on screen. Here I'll connect as Gall tester using the Okta sign-on for user ID and password. We can see that I've had a successful sign-on to Okta, but when I come back to dbeaver, we can see that Gall tester does not have connection permissions to this underlying database. I'll then connect it as Dana tester. So once again, I'm presented the same Okta sign-on screen. I'll connect as Dana tester. Validate against Okta. And when I come back to dbeaver, we can see that Dana does have access to the underlying database and tables. If I come out, do a select against some tables, do a view data, we can see that I have connected through SecuPi, and we can validate some of the rules that I've applied. So in this case, I have a rule for email that does format preserving encryption using the high-level node, but maintaining the low-level domain. In this case, although it's hard to see, I've also encrypted credit card and social security number, but I've done it in a way that's preserved the format of a credit card or social security number. So even though this value has been encrypted, from an application perspective, it's still a valid format for a credit card to be able to do that. If I go into the SecuPi Management Console, look at the dashboard, what I can see are the requests that have been sent through the dashboard for the requests that I've issued. Here we can see a request for Dana tester. We can see that I've identified different classifications to be able to do that. I've also showing that I've done a rewrite of data for that user. If I look at it once again, I can see the classifications for what I've done. In this case, credit card, email, and social security number. I can see what type of rules were applied to it, so I can see that they were rewritten, in this case, using format preserving encryption to be able to do that. I can see some of the rules that are associated with it. So these are actual SAML attributes that I have within Okta to be able to do that. So these are the values that I have for country, group, and administration. So some other things that I have. So I can do this based on the requests that came in, looking through the dashboard to be able to do that. Now, based on the activity that I have, I can also look at things. I can set up analytical alerts to be able to see that. So in this case, I've set up a couple easy alerts to be able to do that. So number of rows, so a number of rows returned were over 100. I'm sending out an alert. In this case, you can see that I have 7,634. I also set up a simple alert to be able to notify me if maybe a user is accessing the database outside of normal business hours. I can do that. And I can also see that I've done it based on Social Security number being accessed. So perhaps that user shouldn't have access to that column. But in this case, I can see that this user, Dana Tester, did and had 14 different requests to be able to do that. We look at real time, what we see are basically requests coming through at a point in time. But I can also look at behavioral analytics over time for particular users using the tool. So not only point in time access for a user that we're looking at, but I can go back based on time for behavior to see, is that user falling within the norms of normal activity for that user? So we can do that based on the user and the median. And here we can see that all of a sudden I do have a lot of requests coming through for this user that are outside the norm or the median for that user to be being accessed for that user. So what we can see then is SecuPi being installed. We can see that I've integrated it with dbeaver, so a client access software tool. I've accessed Postgres without specifying the user password for that, using the authentication underneath with Okta to be able to do that. I've connected to the database without ever knowing that database production user ID and password, and then shown some of the capabilities of the monitoring and auditing that SecuPi provides within the tool. Thank you for your time. If you have any questions, please let us know.